Hello and welcome. For today's discussion, wanted to build on the previous video that was going over kind of a standard IPSec site-to-site VPN tunnel and introduce the concept of filtering traffic across said tunnel and using the VPN filter kind of functionality in the ASA. Um, so yeah, generally the concept is in that video and in that build, all like any and all traffic across the VPN is allowed, and there's plenty of cases where you want to restrict traffic to ports and protocols, so on and so forth. And from that perspective, the best way to go about that is to use the VPN filter. But just real quick, want to just go over some of the routing concepts, even though this video doesn't really touch on routing too much, but just to kind of illustrate the changes from the previous video. One of the things I wanted to do is have the Ubuntu node on the far right to have Apache, and then inside CML that's not there by default. So I needed to get an outside internet connection so I could use apt install to get Apache. So basically that's being done by OSPF, but I kind of want to illustrate that OSPF is running amongst the ASA, this IOSV, which is in the middle, which is kind of like a simulated ISP router. So the simulated ISP, we have some public IP addresses. That's kind of all covered in the previous video. But it's meant to simulate in here kind of like what a real VPN over the actual public internet is like. But additionally need to also be able to get out to the real internet for the purpose of downloading Apache and Ubuntu. And so there's routing amongst these, the ASA and these other routers, but there's no, I want to point out that there's no routing, just like on the public internet, there's not routing for the private IP spaces. So from the context of the CSR, if I do show IP route OSPF, then you'll see that there's no indication of the network that's behind the ASA, which is this 10.50.3 .0 on a /29. So you can see there's no routing to that. This one down here, the 172.16.1.0, that's routing to the actual real internet through the physical network that this CML is connected to. And then the 20.5 is really just kind of the public IP space or simulated public IP space for the ASA. And then if we go to the context of the ASA, and we do show run or show route OSPF, then same concept here. The 12.100 again is the kind of simulated public IP space for the CSR. The 172.16.1 again is like the route to the actual real internet over the physical network. And then again, there's no indication of any routing to the kind of local network behind the CSR for this Ubuntu node all the way to the right, which is the 172.16.20 .0 on a /29. So just to summarize, there is some routing between the ASA and the other routers. So number one, so I can simulate some public IP space and have a real kind of a real world example of a site-to-site tunnel. But on top of that, also give actual real internet access. So I can get Apache on the Ubuntu node here on the far right. And the purpose of that is just when we get into the VPN filter stuff, so we could just do an actual port 80 test from the one on the far left over to the one on the far right, contacting the Apache server that's running on there now. So without further ado, to get into it, the the context, the way this notes are set up, and how I'll kind of describe the lab is that I'm mostly going to be talking about from the perspective of the ASA and the network, that the local area network that it's got attached to it, this 10.50.3.0 on /29. That's kind of be referred to as local. So the Ubuntu local that we have on the far left here, if I do ifconfig, these are on DHCP. Current IP address is 10.50.3.2. So that's why I have Ubuntu local as 10.50.3.2. So when I say local, this is kind of the context on the far left. And the reason why it's going to be important is because we have to pay attention to that in the VPN filter stuff and the access list that's related to that. And then the Ubuntu remote is the one all the way to the far right. So if I do if config, we can see that it's 172.16.20.2. And so that's kind of like the remote network, if you will, and the from the context of the ASA or its internal or network that it's got going on here. So that's pretty much the main context. And then so, what can I do right now? Let's just kind of prove what's working right now. So I'm in the context of the local Ubuntu, and I want to ping to the remote one, which is 172.16.20.2, and we get a ping there. And then of course that is going over the tunnel. There is no routing, from this Ubuntu on the far left to the far right. There absolutely is no just kind of end-to-end routing. The only way that these two separate networks can connect is through the site-to-site VPN, just like that happens on in real-world examples over the public internet. So good simulation of that here in this lab. And then so if I go from the context of the Ubuntu remote, and I want to ping the one on the far left, then I'm going to do a ping 10.50.3.2, and then of course I can ping. So I know the tunnel is up. The only way these two hosts from the far left and the far right can ping each other is because the site-to-site tunnel is working between the ASA and the CSR. And then of course, and as mentioned before, that's just built. So this is just really building on the foundation of the previous video, all the same config generally, so on and so forth. And then, so let's just check SSH. Can I SSH from the local Ubuntu to the remote? So we'll do SSH 172.16.20.2. And I can. So if I do if config, sure enough, I've got a shell from the context of the one on the far right. So I'll log out of that and then just do the same. So now I'm on the far right Ubuntu, we'll do SSH 10.50.3.2. And sure enough, I can SSH in, I do if config, and I've got a shell from the context of this one on the far left. So as kind of stated previously, tunnels up, I can ping in both directions, I can SSH in both directions. And so now we'll see about contacting the Apache server from the local Ubuntu, so from the local Ubuntu to the Apache server on the remote Ubuntu on the far right, and do that over port 80. So I'm just going to run curl, and then it's going to be 172.16.20.2. And then really, this isn't the best example of output or the most visually like looking good type of output, but it gets the job done. So I'm just going to say, so I'm going to use curl to get to it over port 80, but then it's really just going to spit back the all the HTML text for the default page of the Apache server. And so I'm just going to grep on default, and then we'll be able to see, the some of that output. So you can see Ubuntu Apache 2 default config. So it's kind of proving that I can go from the local Ubuntu out to the remote Ubuntu over port 80 and get a response from the Apache server. So basically that's just kind of proving what's working now, because now we'll finally get into the doing the VPN filter stuff. So the first thing that makes sense to do is to create the access list that's going to be used in this VPN filter functionality. Now, the thing about this is you kind of really have to look this up in the documentation, because it uses, Cisco's kind of ACL functionality like they use for many, many things. But there's a major difference here, which is that the way that the documentation will tell you to create these access lists, specifically to be doing this VPN filter stuff, is that the remote network is always in the source position on the ACL. So if you kind of need to be familiar in general with an extended access list, and the fact that any extended access list has, source and destination positions, if you will, and source and destination ports, if we're talking TCP. So the the main thing is, no matter how we ever configure this access list and the various lines that are on there, the thing to keep in mind is the remote network in your topology is always going to be in the source position of the ACL, which means it's in the kind of on the left hand side. So just as a recap, and again, since this is from the context of the ASA, then well, what is the remote network? The remote network is this LAN interface on the CSR, which is this 172.16.20.0/29. And that's where the Ubuntu lives and is getting an IP via DHCP. So basically, I'm gonna start off with this first line, and then we'll build from there. So we know that we need to have the remote network in the source position. So I want to filter on TCP ports in this particular case, and I want to basically make it so the remote network can SSH to the local network. Now, the thing about it is, when we apply this, then all the stuff that we tested previously is not going to work anymore, except for the fact that the remote network can SSH to the local network, because we'll be applying this VPN filter, and then again going back to the concept of Cisco access lists. There's anything past the permit statements in there is an implicit deny, which means that anything that doesn't match on this access list is just going to be denied. And since when we do the initial example of this, there's only going to be this line, then all the stuff that we tried before isn't going to work anymore. And actually, one quick thing that I forgot to show when we're talking about the from the context of the ASA, and we're talking about ports and stuff going back and forth over a tunnel. Well, the thing to know about the site-to-site tunnel on an ASA is that by default, because again, so with this concept of an implicit deny, if we're talking about the ASA, its outside interface, it being a firewall, the default behavior is any traffic hitting that outside interface um, is going to get dropped. And but so how does the VPN traffic get through that? It's because of this sysopt connection permit dash VPN. So I did show run all, pipe include sysopt, and then this specific one, sysopt connection permit VPN, is basically saying, hey, I know the outside interface has an implicit deny rule, and for good reason because it's a firewall. But any site to site tunnel that's up, and we have the valid security associations, then that's got to get allowed. And the point is, it allows everything. So any ports, protocols, any kind of traffic that can go across a tunnel by default will. And then that's kind of part of the background that I forgot to mention earlier. And so now we're going to get into filtering stuff. And then when we do this first part, the only thing that's going to work is SSH. So basically, so we're doing TCP. I've specified the remote network, which needs to be in the source position for the ACL. So we're just kind of following the rules from the documentation. And then the this is going to be the local network. So the 10.50.3 is the local network. And I want the remote network to be able to SSH to the local network. And so that means that I need to put the equals SSH all the way to the right, which would typically be the destination port on an extended access list. But it kind of this is interpreted a little bit different. So again, the concept is I have my remote network and I have my local network, and you always have to keep it that way in this ACL. You won't ever swap that like you possibly would on some other access list. So the positions are always going to be fixed in this example just by following the rules of how this is supposed to work. And so what the key factor here is where you put in the equals for the port or the service. And since I want the remote network to SSH to the local network, it needs to go all the way to the right, which is the typical destination port position in an extended access list. And then what we'll see later on is, well, I want the local network to be able to do HTTP or port 80 to the remote network. So how do I deal with that? Well, you'll see that following the rules of how this ACL is supposed to be configured, again, we have the remote network in the source position, the local network in the destination position, even though that isn't the way that this is actually being or interpreted. So we kept the networks in the same position, but if you compare the SSH one to the HTTP or port 80, you'll notice that the placement changed. So when I want to do the local network to be able to go out to the remote network, then the really only difference here is I'm putting it in the typical source port position in an extended ACL. So not to get too overcomplicated or too wordy about this, but just trying to like explain how this is interpreted by the ASA. So the bottom line is if you want the remote network to be able to do something to the local network, then you need to put your that port or service on the far right, And if you want the local network to be able to do something to the remote network, then you need to put that port or service into the typical source position. And then, as I mentioned, the in the access list structure, the remote network is always in the source position, as we say here. So that may have been a little bit overcomplicated and over wordy, but it just takes looking at it and just practice and testing, and then and looking at the documentation, and it works just fine, as we'll show here. So without further ado, let's actually do something here. So we're in this ASA, we'll go to config mode. And I'm just going to paste in this access list. Okay. So I've got my access list, and the reason why I did that first is because the other stuff that I'm going to be putting in here is going to reference that, so we may as well have it in place first. So the way that this VPN filter is done through a group policy. So basically, I'm going to create a group policy. I'm going to call it ASA2, ASA underscore 2 underscore CSR with the internal keyword. And then this same, referencing the same group policy that I just made, we'll do the attributes keyword. And then let's actually put in an attribute of this group policy. It's going to be VPN filter or VPN dash filter. And then the value is the name of the access list that we just talked about and just made. So we get that in there. So now I have a group policy in place with a name, ASA to CSR. And then one of its attributes has this is a VPN filter, which then references an access list. And so if we do like show run tunnel dash group, then for this, the tunnel group is part of the VPN tunnel config that you have to have. But let's look at what's in here. There's the type of IPSec LAN to LAN. There's IPSec attributes where we put in the key and stuff like that. But there's no, general attributes right now. And that's what we're going to put in is, so basically we're going to go back to the tunnel group, which is part of this VPN config, and basically tell it like, hey, for this VPN tunnel, we want it to reference this group policy, which we call ASA2 ASR, and then that way this stuff will all link up. So go ahead and put that in. So then I guess the way to think about it is, so we'll do show run tunnel group. So this is the peer IP for the CSR, which is what we're peering with for the tunnel. And I have a group policy that's called ASA to CSR. And then so that's our first, we got to start somewhere, and let's see where everything links. So we can start off at an existing tunnel that's working. We've added a default group policy to it, and it's called ASA to CSR. And then when we look at that group policy, one of its attributes is a VPN filter, and then that VPN filter links to or references to this access list that we made. And then if you want to think about another link, then this tunnel group and this peer IP links to the crypto map entry. So if we do show run crypto map, then the set peer statement links to this tunnel group statement with the same peer. So it's just kind of an example of how things link and reference in various parts of the config. So it kind of all comes together. So now, so the only thing that should work here because now we're filtering over the tunnel at this point. The VPN filter is all in place. We've done all the config that's necessary. And so really the only thing that should work over the tunnel is when the remote network tries to SSH to local. So let's see if that's actually the case here. So I should just be able to ping. Well, I shouldn't be able to, but I'm going to try, right? So I'm going to do what we did before, which is try to ping from the local Ubuntu to the remote. And I do get a ping. And why is that? So this VPN filter stuff doesn't actually take place until you clear the security association for the tunnel. So we'll do clear crypto v2 SA, and then let's see if it's so now I can't ping, right? Because now the tunnel will be back up, but now the ASA is running that VPN filter. So if I do show crypto like v2 SA, then tunnel's back up because I sent interesting traffic, which was enough to build the tunnel. But as you can see, and if we do, so we can see here it negotiated. That's the phase one. So show crypto IPSec SA, and then I actually don't see any end caps. Well, that's probably because of the that's actually for sure because of the filter that's in place. So let's do something that still should work. Let's SSH, and then sure enough, then I'm SSH'd into from the remote to the local, just like we expected. And sure enough, that works because the VPN filter is allowing it. And let's go back to let's look at the SA again. And then of course, so that's actually a good example. So like when, so to kind of recap, we set the filter configuration, all the little things that need to happen to tie that all together. And then I was like, oh, well, let's see if I can ping still, because I shouldn't be able to. But it did ping. And the reason for that is because the VPN filter, even though it's in the config, it's not really taking place until we cleared the security association for the tunnel. So basically just took the tunnel down, cleared any security association, and then what did I do next? I sent some ping traffic, which of course didn't work anymore because of the VPN filter. But then I started looking. That was enough to build to get the tunnel to build overall. But then when I looked at the so again, here's the showing that the tunnel was up because I did send interesting traffic, but it got denied by the VPN filter. So maybe that wasn't what to build the tunnel. But at any rate, when I looked at the phase two, so I did show crypto IPSec SA. I shouldn't have any end caps because it's not going to encapsulate anything for encryption if it's getting blocked by the VPN filter. So that all makes sense to me, and why I wouldn't. So I'm sending what typically would be interesting traffic, but I don't get any phase two end caps because it got denied before it would have went through encryption. But then, of course, we cleared the tunnel and did something that actually would be allowed, which is SSHing from the remote Ubuntu to the local. And then sure enough, that of course did work. And then we looked at the phase two again, and I started seeing end caps and decaps, obviously, because the SSH worked and that populated that. Okay, so and let's do something else that worked before that is not going to work now. So, previously from the local Ubuntu to the remote Ubuntu over port 80 to hit its Apache server that was working before. And then now I get a connection refused. Well, why is that? Because when I'm sending from the local Ubuntu, it's hitting the ASA, it's getting evaluated, and it hits that VPN filter. And again, so at this point, there's only one thing that's being allowed. If I can get the right window here, there's only one thing that's being allowed, which is this remote network and SSH to local network. So of course, when I try to go from the local network to HTTP to the remote network, then I'm getting a connection refused, and that tells me that the ASA is actually sending a TCP reset. It's not even silently dropping it; it's sending a TCP reset based on the fact that like that traffic that I sent the curl over to the remote Ubuntu's Apache. That's not allowed because it doesn't match on this access list that we made for the VPN filter, and there's an implicit deny there. It's denied, and in fact, it even just sends a TCP reset. Okay, so let's start adding back in the stuff that worked before. Because at this point, like you have one thing on the access list for the VPN filter, that's all that's going to work across the tunnel. So whatever else you want to have work across the tunnel, now we got to start adding that stuff back in. So let's do the next one on the list here, which is I want the remote network to be able to ping the local network, and then again, well, and so what's different here now? Before we were talking, SSH, which is, TCP, but if we're talking ping, then now we're talking ICMP, which is like a routed protocol, layer 2, layer 3, if you will, but it certainly doesn't have anything above layer 4. And so instead of saying permit TCP, we'd say permit ICMP. And then we're just kind of forced into doing the access list, configuring the access list by the rules, which is always having, from the context of ASA, always having the remote network in the source position and having the local network in the destination. So we want the remote network to ping. So let's put this in and we'll see what happens. So let's see. So we'll go, and then sure enough, it's working right away. Okay, so that all makes sense, and we're still kind of going along logically here. And let's just double check again. Let's do curl, and of course, connections refused. So at this point, we can ping across the tunnel. And actually, I think this will probably, the one thing that I failed to do in kind of researching this lab is I have it saying remote network can ping to local, but this is probably just going to allow both. So this rule here is probably not directional. And let's see if that's the case. So 20.2. So I can ping. So what I should really say is the way this is set up, and you may be able to do only in one direction or whatever. Not too sure about that. That would be something I'd have to research and think about. But really what this should be called is ping is allowed bidirectionally. So that's actually what's going on here. So when I was figuring out how to do this access list for ICMP, basically it'll just work. We're switching it over to ICMP instead of TCP, And then we just have the normal thing where it's remote network is first or in the source position, and the destination network is in the destination position. But it doesn't, it's just really, you have to have it that way. You have to have from the context of the ASA, the remote network is in the source. And so really what's happening is we're just defining the two networks that are, this is really the VPN encryption domain. And we're in our access list, we're just kind of replicating that again. Like here's the two networks that are in the encryption domain, and just let ICMP go back and forth no matter who initiates it. That's what's really happening in this access list here. And then finally, let's just do the last one, which is let's make it so I can go from the local network to the remote network over port 80. And then again, just to recap, the only change here from the other TCP one where we're doing SSH is since we want to swap the initiator, since I want the local network to initiate and have a destination port of 80, then I have to move it into this position, which is typically the source port position of an extended access list. So I feel like the more I talk about it, the more I'm probably confusing it, and it's probably just easier to just look at it and eventually get it with practice. So I'll just paste that in. And then let's see if I have to clear anything, the SA, or if this will just run. So we'll do the curl again, which it did run. So that's interesting. Oh, maybe it's the first time. That's probably what it is you have to clear the SA on the first time that you instantiate this VPN filter, if you will. But any subsequent adds to the access list, then they just immediately work. So that actually does make sense, and I'm kind of realizing that in the course of creating this video, which is cool. I'm always trying to like learn stuff on the fly, and even if it's in the midst of making a video, while trying to, I guess, prove to myself and other people that actually know what I'm talking about. So I don't think that was messed up too much in the course of this recording. So I think that's pretty much it for the video. I guess to summarize, site-to-site tunnel, everything's allowed by default. If we want to filter it down, then we need to make a group policy. We can use the VPN filter functionality of group policies. That then gets linked into the tunnel group config for that specific VPN tunnel that we're talking about. And we just reference the group policy that we made. And then the mechanism by which what is allowed or what is not allowed over this VPN filter function is the access list that we made. And then so, but it's, again, as soon as you start putting something in an access list, then anything that doesn't match is going to be not denied automatically. So you have to, anything that you want to go across a tunnel now has got to be put in explicitly. And so actually, what's the very last thing that should not work that we did previously? Because previously we were doing SSH in either direction. So the local machine could SSH to the remote could SSH to the local. But then right now, the only thing that we have in the VPN filter is that remote can go to local. So then I should try local to remote, and that should not work. So I'm on the, on the far left again, the Ubuntu local. Then if I do SSH 172.16.20.2, connection refused. So, well, why is that? Because it doesn't match in the VPN filter. The ASA sees it and is like, nope, I'm dropping this. And not only am I dropping it, I'm going to send a reset to the person that sent it, to the machine that sent this packet in the first place. So that just kind of proves that, like, so now we can ping back and forth, no worries. I can SSH from remote to local, and I can port 80 from local to remote and nothing else. Any other traffic that doesn't meet these access list lines here would just be denied. And we saw that with me trying, just right now is me trying to SSH from local to remote because it's not in here, but remote to local is. So just one last time, SSH. We want to go from remote to local, which is going to be then 10.50. What is it? 3.2. And then, of course, I can get in because it's allowed in the VPN filter. So that is it. And hopefully that made sense and I didn't overcomplicate things in trying to describe the way that the access list is interpreted. At any rate, you never really understand any of this stuff until you actually implement it. That's what the purpose of this video is. So hopefully that's all helpful. Thank you for watching. Have an awesome day and we'll catch you next time.